Welcome to Math Challenge Problems. Today we're going to write the equation of the circle given a tangent line and the coordinates of the center of the circle. Let us have this problem. Write the equation of the circle that is tangent to the line 3x minus 4y equals negative 3 and the center is at 0, 7. From the standard form of the equation of the circle, x minus h squared plus y minus k squared equals r squared, where the center is at hk and r is the length of the radius. In here, we can say that to write the equation of the circle in standard form, we first need to identify the coordinates of the center, which is hk, and the length of the radius r, and substitute it to the standard form of the equation of the circle. In this problem, we are given a circle that is tangent to the line 3x minus 4y equals negative 3, and the center is already given at point 0, 7. Let us have the diagram or the figure not drawn to scale to represent the given information. So to solve for the length of the radius, we need to identify the point of tangency and find its distance with the center of the circle. To find the coordinates of the point of tangency, we need to identify the equation of the line containing the radius. And when we have that equation, we can solve it simultaneously with the equation of the tangent line to find the coordinates of the point of intersection. And then we can find that distance from the point of intersection to the center to solve for radius. Let us do that. Since we know that the radius is perpendicular to the tangent line, we can identify the slope of the tangent line given in standard form 3x minus 4y is equal to negative 3. If the equation of the line is given in standard or general form, the slope is given by negative of a over b, where a is the coefficient of x and b is the coefficient of y. Hence, the slope of the tangent line, let us represent that by m sub t is equal to the negative of 3 over negative 4, and that is 3/4. Hence, the slope of the line containing the radius is the negative reciprocal of 3/4, and that is negative 4 over 3. Since we have the coordinates of the center of the circle, that is a point on the line containing the radius. So we can use the point slope form to find the equation of the line containing the radius. So we have y minus y sub 1, that is 7, equal to the slope, negative 4/3 times x minus x sub 1, that is 0. Multiplying both sides of this equation by 3, we get 3y minus 21 is equal to negative 4x. And rewriting this in standard form, we have 4x plus 3y equals 21. Now we can solve the equation of the line containing the radius and the tangent line simultaneously to find that point of intersection. Let the equation of the tangent line be equation 1, that is 3x minus 4y equals negative 3. And the equation of the line containing the radius be equation 2, that is 4x plus 3y equals 21. Our solution will be elimination by addition or subtraction. To do that, we need to multiply all terms of equation 1 by 4 and all terms of equation 2 by 3, and then subtract the resulting equation to get rid of x, or to eliminate x. Then we have, for equation 1, 12x minus 16y is equal to negative 12. And for equation 2, we have 12x plus 9y is equal to 63. Subtracting the two equations term-wise, we have negative 25y is equal to negative 75. Dividing both sides of the resulting equation by negative 25, we have y is equal to 3. And to solve for x, we substitute y equals 3 to either equation 1 or equation 2. Let us use equation 1. So we have 3x minus 4 times 3, that is y, is equal to negative 3. So we have 3x is equal to negative 3 plus 12, that is adding 12 to both sides of the equation. Then 3x is equal to 9. Dividing both sides by 3, we have x is equal to 3. Hence, the point of tangency is at point 3, 3. Now we can solve for the length of the radius using the formula for distance between 2 points, and that is equal to the square root of x sub 2 minus x sub 1. So we have 3 minus 0 squared plus y sub 2 minus y sub 1, that is 3 minus 7 squared. So we have the square root of 9, that's 3 minus 0 squared, plus 16. So we have r is equal to the square root of 25. Squaring both sides, r squared is equal to 25. Hence, substituting the coordinates of the center 0, 7 and r squared equals 25 to the standard form of the equation of the circle, the required equation is x minus 0, so that will be x squared plus y minus 7 squared is equal to 25. There is another solution to this problem that is an easier one to use. So from the standard form of the equation of the circle, we know that we need to identify the coordinates of the center and the length of the radius to write its equation. From the given information, we have a circle that is tangent to the line, and the coordinates of the center is given. If you are already introduced to the formula for the distance between a point and the line, that is given by d is equal to the absolute value of a x sub 1 plus b y sub 1 plus c over the square root of a squared plus b squared, where a, b, and c are the coefficients of the equation of the line written in general form, and x sub 1, y sub 1 are the coordinates of the given point. In here, the equation of the tangent line is the given line, so we have 3x minus 4y plus 3 equals 0, where a is equal to 3, b is equal to negative 4, and c is equal to 3. And the coordinates of the center, that is 0, 7, is the given point, that is x sub 1, y sub 1. Substituting these values to the given formula for the distance between a point and a line, we'll have the distance as the length of the radius, and that is equal to the absolute value of 3 times 0 minus 4 times 7 plus 3 all over the square root of a squared, that is 3 squared, plus b squared, that is negative 4 squared. So we have 3 times 0 is 0. Negative 4 times 7 is negative 28 plus 3, that is negative 25. Absolute value, that is 25. 3 squared is 9. Negative 4 squared is 16. So we have 9 plus 16. So square root of 9 plus 16 is square root of 25. So that will be 5. Hence, r is equal to 25 over 5 or equal to 5. And from here, r squared is equal to 25. Since we know the coordinates of the center of the circle, that is 0, 7. So we have the equation of the circle in standard form as x minus 0 squared, so that is x squared, plus y minus 7 squared is equal to 25. That will be all. Thank you for watching. Please subscribe for more math challenge problems.